These videos have been produced on-site in a large fabrication facility, and we ask your understanding for the environmental background noise. The Copper Development Association is pleased to present a series of video presentations covering the welding of copper-nickel alloy. This video is the fifth in a series designed to provide welders with the principles of joining 90-10 and 70-30 engineering grades of copper-nickel. To recap, in our first video, we covered preparation for welding. Maintain a high level of cleanliness and avoid contamination, which can cause weld cracking. Preheat and post-weld heat treatments are unnecessary. There are elements that even in small amounts are very detrimental to copper-nickel alloys, and if present on the surface before welding, they can cause embrittlement and cracking. The elements that are particularly harmful are lead, sulfur, phosphorus, and other low melting point metals. We are assuming that all viewing this video are familiar with the basics of welding, and our message is to point out where the copper-nickel alloys are different and exceptions are needed. Here we consider the pulsed arc MIG welding process.
In this segment, we'll be demonstrating the pulsed gas metal arc welding process. Gas metal arc welding is also called MIG welding. There are three major forms of metal transfer in the process: the short-circuiting transfer process, otherwise called short arc, the spray transfer process, and the pulse transfer process. Pulse gas metal arc welding has an advantage of being the best of both the short circuit transfer and the spray arc process. The short circuit transfer uses lower voltages and can be prone to lack of fusion, and as such is typically only used on thin materials. The spray transfer process has very high deposition rates and typically is only used on thicker materials in the flat position. The pulse process again combines the best of both of these processes by reducing the heat input and allowing good out-of-position operation with sound weld deposits in any position.
Some of the advantages of the pulsed MIG process are reduced spatter compared to short-circuiting, giving increased deposition and minimum cleanup. Lower fume levels. Better control of heat input, allowing less distortion. Lower tendency for incomplete fusion than with short-circuiting transfer.
We'll be using a particular pulsed gas metal arc power source and wire feeder. It's important to note that there are many manufacturers of such equipment. For the equipment we're using the parameter data that we obtain from the manufacturer. In every case, check with the manufacturer of your equipment to get the best parameter sets for welding the copper-nickel alloys. In this segment, we'll do pulsed gas metal arc welding with 70-30 copper-nickel welding wire. In this case, we're using 35 thousandths of an inch diameter wire. There are other sizes available, such as 45 thousandths of an inch, 1/16 of an inch. The larger sizes are typically used on thicker materials where greater productivity is desired. For any of the MIG processes, an inert shielding gas is used. 100% argon may be used. Many prefer using argon-helium mixtures, with the helium percentage ranging from 15 to 25%. In this case, we'll be using a 75% argon, 25% helium gas mix. As with other processes, we're circling back in on the start to help burn out any crater defects. We're holding the gas cup close to get good gas coverage, and we're doing a very slight weave to ensure that we have good fusion to the sidewall. Arc length is typically determined by the power source wire feeder settings, and therefore it's not real critical with the amount of standoff for the tip in the gas cup.
After the weld is made, post-weld clean to a bright finish and visually inspect the weld to assure that it meets desired quality, the proper weld contour, and is free of defects such as cracks, undercut, and lack of fusion and penetration. In addition to these video presentations, there is also free printed and downloadable literature covering all aspects of copper-nickel alloys, including fabrication, welding, and corrosion resistance.